Good morning, everybody. I'd like to take a few minutes to talk about powers, bases, and exponents. So I think we all know that this little number right up here is the exponent, and what that does is it tells you how many times to use the base as a factor. In this case, we have the example 2 times x to the 4th power. 4 is the exponent, x is the base. 2 is what we call a coefficient, so it's like a multiplier that comes right before the base. Now when we talk about the power, a power is the same as the base and the exponent. So in our example here, our power is x to the 4th power. And that is what we call the power. It does not include the 2 because the 2 is a coefficient. In this case, the x is the only thing being raised to the power of 4. So I'd like to talk about another example now. This sheet is in your packet, and you're going to see the questions here. Is negative 2 to the 3rd power equal to parentheses negative 2 raised to the 3rd power? Now, the only difference between the left side and the right side here are the parentheses. So what that means is that in each case, we have a different base. On this side, my base is only the 2. Over here on the right, my base is everything being raised to the 3rd power, so my base is actually negative 2. So over here, my base is this whole quantity of negative 2. Over here, my base is only the 2. It does not include the negative. So when we look at the left side, if we want to expand that out, what we really have is a negative times a 2, 2, and a 2, which gives us a negative 8. On the right side, our base is negative 2, so what we really have here is negative 2 times negative 2 times negative 2. In both cases, we get the same answer, but they are a different kind of a problem. If we look at the example below, is negative 2 to the 4th equal to parentheses negative 2 to the 4th? Again, on the left side, we can see that the base is only the 2, whereas on the right side, the base is everything in the parentheses, which is the negative 2. So on the left, when we expand that out, we have negative 2 times 2 times 2 times 2, or negative 16. On the right side, we have negative 2 times negative 2 times negative 2 times negative 2. So the negatives cancel out. We have a positive 16 here. These are not the same. Neither are these, but you get the same answer. Over here, we don't. So we really have to be careful. When we have a negative base raised to an even power, the negatives go away and we get a positive result. And when we have a negative base being raised to an odd power, you get a negative result. So negative base raised to an odd power, you get a negative result, and a negative base raised to an even power, you get a positive result, which is kind of what you see down here at the bottom of your screen, okay?